So while that solution of acetanilide is cooling, which is going to take a while, in order to be efficient, we might as well start getting the second step set up. And the second step is also going to be run in 125 milliliter Erlenmeyer. I'm going to go ahead and use the same stir bar. It's still a little wet, but it's aqueous solution anyway. And we need to measure 1.8 grams of sodium bromide and dissolve that in a mixture of 6 mils of the 95% ethanol and 5 milliliters of glacial acetic acid. I've still got my pipette that I was using for water. So I'm going to go over to the balance and measure out the 1.8 grams of sodium bromide. We'll just tear that whole flask. Stir that up a little bit since it's a little chunky. That's about half a gram. So I got 1.9 in there. It's a little too much. Take a little bit out. .88. And it's 1.809. I'm going to call that good enough. So 1.809 grams of sodium bromide, which we are now done with. And we want 6 milliliters of this 95% ethanol. So I'm going to leave 4 in there. Set that aside for later. And now we're going to measure out 5 milliliters of glacial acetic acid. no need to scrub that. We're just going to rinse that with water. Flush the rest of the acetic acid. Nice thing about a green synthesis like this is not a lot of organic waste being generated. And we're going to set that up on a stirring hot plate, the one that isn't still hot. And stir that. See if we can get that to start dissolving. And we're going to need that ice bath again, so I'll go get some more ice. It's a pretty common technique in organic chemistry to start a reaction off at a very low temperature, because it'll be a little exothermic as the reaction starts, and then gradually allow it to warm to room temperature over time. Add a little bit more ice to this ice water bath that we're going to use to rinse our acetanilide after filtration. And we'll just leave those sit so they're ready when we need them. Probably won't all dissolve until we add the sodium hypochlorite solution. And this sodium hypochlorite solution is 0.7132 molar. That was titrated. It was titrated last year, though. It's probably not exactly 0.7132 molar. I am adding 10.78 milliliters according to the pre-lab calculation of that 0.7132, but I'll probably add more like 12 because I suspect that it's not quite the concentration that it says it is. So I'm going to go ahead and measure that out too, so it's ready when I need it. And it's about 12 milliliters. So after we filter the acetanilide, once it crystallizes, we're going to dry that in a desiccator so we can get a yield, and then we're going to take 1 gram of that solid and add it to this flask before we add the bleach solution. So that's just going to sit there and stir. Swirl it around, try to get some of those chunks to dissolve. It takes a long time for that to dissolve, so you might as well have that happening while we're waiting for other things to happen. This is probably cool enough now that I can disconnect it from its moorings. You can see that we're starting to get some nice needles, right? Some fairly long crystals. The slower it cools, the nicer the crystals and the less likely we are to trap impurities. So I want to let that cool nice and slowly. Let's stick that in the back, and that way I can use this guy to clamp the new Erlenmeyer flask so it doesn't walk its way off the stir plate. And I'm not going to cool that in an ice bath yet because I want that sodium bromide to mostly dissolve before I do. Need to cool it in an ice bath before I add the bleach, but not sooner. And I'm going to crank that way up. Let that stir at 600. And we're just going to let that cool slowly. So I'll turn this off again for